All right, good morning, Katie. I figured the easiest way would be to send you a video, and I'm just going to preface this with saying that this is my best solution, by no means a professional solution here. So, from what I can remember, many years ago. Okay, so we start off with, I believe this is the limit that you're asked to evaluate at a point. And remember, evaluating at a point for an implicit function like this is a little different than you did with me when we evaluated at just a single x value. So we have this. First thing that I would like to try is if x equals 0. I want to evaluate if two cases, if x equals 0 and if y equals 0, and make sure they're the same. So if x equals 0, we're going to get 0 over y to the fourth, which is 0. And if y equals 0, we're going to get 0 over x to the fourth, which is equal to 0. I believe if those two were different, then the limit would not exist. So then what I'm going to do, limit as x, y approaches 0, 0. Okay, I'm going to separate, see this x, I'm just going to kind of rewrite it a little bit. Same expression, rewrite it like this. And the reason I'm going to rewrite it like that is because now we can say that this quantity y to the fourth over x to the fourth plus y to the fourth has to be greater than or equal to 0, because these are all raised to an even power. So positive plus a positive has to be greater than or equal to 0. However, it is also less than or equal to 1. So we've now squeezed it or trapped it between 0 and 1, that quantity at least, because you have y to the fourth, you have y to the fourth, and you're adding on a positive quantity to the denominator. So the denominator is always going to be larger than the numerator. So I'm going to take a look now at two cases. Case number 1. What about if x was greater than or equal to 0? If x is greater than or equal to 0, so then what we're going to have, we're going to be multiplying that by y to the fourth over x to the fourth plus y to the fourth, something like that. And if we're going to multiply a quantity that's greater than or equal to 0 and less than or equal to 1 by a positive quantity, then this is still greater than or equal to 0, but now it's less than or equal to, and I'm just going to throw an absolute value of x there because I think you had mentioned the absolute value of x. So that would be less than or equal to the absolute value of x. Again, because this quantity is between 0 and 1, and now we're multiplying it by a positive number x, so it's greater than or equal to 0, but now it's less than or equal to absolute value of x. Second case, what about if x is less than or equal to 0? Well, if x is less than or equal to 0, in other words, if it's negative, and now we're going to multiply it by this quantity, which is between 0 and 1, then we know that it's going to be negative, so it's greater than or equal to negative absolute value of x. Again, we're multiplying this quantity by x. But it's going to be negative, so it's less than or equal to 0. So now, if you think about this, what we've just done is we've taken this quantity, in either case, it's greater than or equal to 0, but it's also less than or equal to 0. So we've squeezed it, and we now know enough to be able to say that the limit as xy approaches 0, 0, the expression xy to the fourth, which is this, over x to the fourth plus y to the fourth is equal to 0. Again, that is my best attempt at what your professor is looking for here in this problem. Please get back to me with any questions or thoughts you have, and